Hello, today we are going to cover lesson 8.6, Law of Sines and Law of Cosines. By the end of this lesson, you guys will be able to solve triangles using both of these new laws, and they are also our new vocab terms. So we're going to start out with a quick review of a trig function. We are going to try to solve for x using angle A and then using angle C. So, to use angle A, we are going to look at this triangle here, and we have opposite and we have hypotenuse. So based on SOHCAHTOA, we are going to use our sine function. So we have sine of 59 degrees is equal to opposite over hypotenuse. Go ahead and solve for x. And we end up getting, as you'll see here, 5.14x. Now if we solve using our c degree, once again we're looking at a different triangle. But this happens to be also opposite and hypotenuse. So we have sine of 40 degrees this time equals x over 8. Go ahead and multiply 8 on both sides to solve, and we end up getting x is equal to 5.14 as well. Now you can tell on the calculator they are not exact, but they are exact rounded to 100th, and I would say that is close enough. Alright, so law of sines, our new thing today in lesson 8.4. You use trigonometric ratios to find side lengths and acute angle measures in specifically right triangles. To find measures for non-right triangles, the definition of sine and cosine can be extended to obtuse angles. So for the law of sines, you can use this to find side lengths and angle measures for any triangle. So we have a formula here. It's really just a proportion. So you take sine of A over the opposite side A equals sine of B over the opposite side B. You really only need to do 2 of these. You don't need a 3-stepper. So if you don't have the B part, you could take sine of angle C over the opposite side C and solve. Let's try one. So we're going to find P, round to the nearest tenth. So we're trying to find this guy here. It's a side length. So we are going to take sine of 17 degrees over the opposite leg, P, equals sine of 29 degrees over the opposite leg, 8. And once again, we're back to that good old cross multiplication. We end up getting 8 sine 17 is equal to P sine 29. Now we are trying to solve for a variable, so we go ahead and divide both sides by sine of 29. I'll go ahead and pull this up. So we have 8 sine 17 divided by, let's see, put the answer up there, over sine of 29. And we end up getting that P has to equal 4.82, says round to the nearest tenth, 4.8 units, whatever you want to call it. P is 4.8 long. Okay? So, law of sines, just another proportion problem. Now we use the sine trig function instead of just numbers. Same thing, find C to the nearest tenth. Well, you take angle C, sine of 23, over side length C, equals angle A, sine of angle A, I should say, over 16. Go ahead and cross multiply. We end up getting 16 sine 23 equals c sine 47. We want to get c by itself, so we divide by sine 47. Go ahead and plug this into your calculator. Oh, make sure to completely clear. 16 sine 23. Oh, see, careful. We don't want to do that. Can we do divide the whole thing? Yep. And then I like to, when I'm trying to do something new with the calculator, make sure if I put everything in like that, that the calculator actually does it correctly. So I do it all together, and then I do it in multiple steps, just to make sure something doesn't get missed. So, yes, all together and through the multiple steps, we end up getting that side length C has to equal 8.55. Once again, round to the nearest tenth, so 8.6 units. Okay? Now we need to find angle measure B, round to the nearest tenth. So, we're finding angle measure B. Good thing we have our opposite side from angle C. So we have sine of 88 over 41 is equal to sine of B over 31 oops, meant to say go ahead and cross multiply. Get 31 sine 88 is equal to 41 sine B. We want to go ahead and divide both sides by 41. And then we've kind of come to a bit of a roadblock. We need to recall from a couple sections ago that to find angle measures versus side lengths, you are going to end up taking the inverse sine of this whole thing. So this is what it'll look like in your calculator when you plug it in, okay? So we need to do that. We need to take the inverse sine of 31, sine of 88. This, if you are not using this Desmos calculator, I would definitely do in multiple steps, just because it's hard to make sure that the calculator is actually doing it correctly. So that degree, angle B, is actually 49.1 degrees. If we were to solve angle A using a similar method, we'd be able to find it as well. Okay? Now, let's look at another one of those just so we can get a good idea. We're going to find angle A this time. This triangle looks definitely way different than the previous one. And round to the nearest tenth. So we set up a law of sines problem. It's just a proportion, sine of 74 over 26, opposite from each other, equals sine of A over 7, opposite side, okay? Cross multiply, so we have 7 sine of 74 equals 26 sine of A. Go ahead and divide both sides by 26. Now, because we are finding an angle measure versus a side length, we need to use the inverse of sine. So your problem will end up looking like the inverse of sine of 7 sine 74 degrees over 26, okay? So we plug that in. I'll show you real quick what it would look like to do it in multiple steps. You would do 7 sine 74 equals that. You would divide that then. Answer divided by 26. And then you would take the inverse sine of your answer. So that is the multi-step version. If you are using a normal calculator, I would do it that way. I would not try to plug it in all at the same time. So we have inverse sine. I'm just going to do it, show you that they end up getting the same thing. Notice on this calculator versus with the multi-step or with the all together, we end up getting that we have 14.9989, which means I'm just going to round up to 15.0 for the degrees of angle A. Okay? Now, law of sines cannot always be used to find side lengths or angle measures. When the law of sines cannot be used, we use the law of cosines if that applies. So if ABC has lengths A, B, and C, triangle, representing the lengths of the sides opposite the angles with measures A, B, and C, then we have these guys. Now, they might look a little confusing. You can look at the diagram. We're going to go through them, try to figure them out together with a problem, okay? So let's paste this down here, figure out which one we need to use. So, we have, kind of like the Pythagorean theorem, this information. Basically, what you want to pay attention to is your term that actually has a degree. The angle that has a degree becomes the one that goes down here. So in this case, angle X has our degree. So we have X squared, the side length we're trying to find, equals, I don't care what B and C are, 11 squared plus 25 squared minus 2 times 11 times 25 times cosine of 45. So it's the same sort of pattern every time. The number with the angle or the side length with the opposite angle is the one that is equal to it. The other ones are repeated, and then that degree is with the cosine. Then we go ahead and solve. I will say law of cosines is a little more tricky than law of sines. Law of sines is basically like we've been doing for the past few weeks. Just a bunch of proportions. Whoops. Make sure you know that that is actually cosine of 45. 550 times cosine 45. Oops, did not put answer. Times cosine 45 equals actually a very big number. Probably going to want to use that as an answer version. So I'm actually going to go, so that way I don't have rounding errors or anything crazy like that. Just going to plug it all in at the same time. Oopsie. And we get our solution of 357. Oh, that is not our solution yet. I almost made a bad mistake. That actually equals x squared. Then we have to take the square root. Oh, man. We have to take the square root of that answer to get our actual solution. There we go. That makes a lot more sense. So we finished solving that, just like that. All right, let's do another one. So we have find r, round to the nearest tenth. So we're finding this side length. Notice we have the angle across from it, and we have the two sides. It's kind of like a side angle side. You'll see that up here, law of cosine, side angle side. We need to set up our formula. So we know that the side length opposite of the angle given is the squared one. The one that it equals, I should say. Then we have 15 squared plus 32 squared minus 2 times 15 times 32 times cosine of 40. Now this is a nice big long formula. It's okay, we can do it. 15 times 15 is 225. 32 times 32 is 1024. And we'll go ahead and add those together. We end up getting 1249. Then we need to take 2 times 15 times 32, 960 cosine of 40. Then I think we can just do it all together, or we can do it separately. I don't really care. We'll do it separately just to show you those steps. 960 cosine of 40 is equal to 735.4. Go ahead and subtract those. Oh man, I keep doing that. Answer? Yes, there we go. So we have that r squared is equal to 513.597, We just really care about what the square root of that is. So our solution for the length of r is actually 22.7 units, somewhere around there. Okay? And keep going. You can also use the law of cosines if you know 3 side measures, side, 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 so we can find degrees. We're finding L, round to the nearest degree. So if we're finding that L, we know we need to use cosine L. So these two are the 2 times 5 times 27 that are subtracted. And then we have the one across from the L squared equals the other 2 added and squared. So it's just this formula that you just fill in based on the information you have and you want to solve for. So we have 5 squared plus 27 squared. We also have 24 squared. Oop, not the square root. My bad. And then we have, 10 times 27, or 270, cosine of L. Now our variable is an angle measure now, so we know we're going to have to use the inverse of cosine eventually. Until we get to the cosine part, it's really a lot like normal. So we get thus far that cosine L is equal to 0.659. I'm not going to round this because I know I'll have rounding error then. I'm going to take the inverse cosine of what is on my calculator. That is the 178 divided by 270. That is this decimal here that you see. I'm going to take the inverse cosine of that because I'm trying to find a degree. And then I will have my solution. So the degree of L is actually 48 point, to the nearest degree, 49 degrees. There we go. Notice if I did inverse cosine, maybe I should go down a little. Inverse cosine of that fraction that I have versus the decimal that I found, it's going to get you the same thing. See? So either way you do it, you're good to go. Let us do another one like that. Round to the nearest degree. We are finding the measure of angle P. So once again, we have the side, side, side. We know the opposite side of the degree we're trying to find is the squared equals the other two squared. It's kind of like modified Pythagorean theorem, actually. And then subtract 2 times 1.3 times 3.1 cosine of the degree P in this case. Okay, now we just have a bunch of solving to do with decimals. So 2.9 squared is 8.41. 1.3 squared is 1.69. 3.1, oh man, I hate when I do that. 3.1 squared is 9.61 minus 2 times 1.3 times 3.1. Cosine of P. Can't forget that part or else the problem's wrong, okay? Go ahead and add 1.69 plus 9.61. We end up getting this guy. Keep solving. I'm trying to find an angle measure, I always do the inverse. So once I find this fraction, I'm going to take the inverse cosine of it. So you can look over here on the calculator. I'm going to do inverse cosine of negative 2.89 divided by negative 8.06. And you notice because these are both negative, you can actually get rid of the negatives. We know that fraction has to become positive. So we end up getting that the measure of angle P is equal to the nearest degree, 69 degrees. Okay? And then we need to solve the triangle for the next two. Solving the triangle means just make sure to find all the angle measures and all the side lengths. Notice we are given all the side lengths, no angle measures. That means we need to use the law of cosines. Same thing in this case on the next one, at least to start. So I'm going to find the measure of angle P, because why not? So I'm going to have cosine of P, and then I know 8 squared is going to equal 7 squared plus 9 squared minus 2 times 7 times 9. Now I go ahead and solve. we'll go ahead and actually just finish that out. There we go. Oops, that should be an equals here. My bad. Sorry if you wrote that down. So we end up getting, because we're finding an angle measure, the inverse cosine of, once again, they're both negative, so 66 divided by 126 is equal to 58 degrees. Okay, and then angle Q, now that this is 58 degrees, we can actually use the law of sines. So we can mix it back up. I think the law of sines is actually easier. So I'm going to transition. I'm going to use the law of sines instead. I'm going to solve for angle Q and say, okay, so sine of Q over 7, the opposite side, equals sine of 58 over 8. And then I simply cross multiply. I end up getting 7 sine 58 is equal to 8 sine a Q. Divide by 8. And then because I'm finding a degree once again, I go ahead and I do the inverse sine of this whole thing. So I take the inverse sine of 7 sine of 58 there over divided by 8. We end up getting that is 48 degrees right there. And then angle R, I'm actually going to go ahead and use the law of sines again, and then I want to talk about another way you could show or answer it. So I'm going to use the law of sines. I'm going to say that sine of R over 9 is equal to sine of 58 over 8. Notice I used the same proportion on the right side as I did the last time. So I get 8 sine R is equal to 9 sine of 58. Divide by 8 on both sides. Once again, finding a degree, so I need to take the inverse sine of this whole thing to find my solution. I could have solved all of these using law of cosines if I wanted to. I do prefer law of sines though, so it's really up to you, whatever you prefer. So this ends up being 73 degrees. Now, the way you can check this is you know that these angle measures actually have to add to 180. Now, because I am having you round to the nearest whole degree, there might be a tad bit of rounding error. We might get like 179 or 181 just because we rounded differently like we did here. But no, with the rounding error, you should be within 1 degree either way to getting to 180. If we had kept more tenths, hundredths, it would have been even more accurate. And lastly, we're going to solve RST, round in the nearest degree. Once again, we have to start with law of cosines. I'm going to solve for angle t using law of cosines. So I have 9 squared equals 12 squared plus 14 squared minus 2 times 12 times 14 cosine of t. Now we solve. 81 equals 144 plus 196 minus whatever 2 times 12 times 14 is. Cosine of t. Go ahead and keep solving. So we take the inverse cosine. Whoopsie, did it again. Inverse cosine of 259 divided by 336, and we end up getting that angle t is 30, 40 degrees when rounded. Once again, that rounding error might throw us off a little bit, but should be close to that 180 mark. This time I'm going to keep going with inverse cosine because that actually introduces the least amount of rounding errors. So I'm going to find angle r based on inverse, or the cosine idea, law of cosines I should say. So if I need to find angle r, I know we have 14 squared equals 12 squared plus 9 squared minus 2 times 12 times 9 cosine of r. I go ahead and solve these. And we get some answers, gotta keep working through it. You'll notice over on the side that I already did a lot of these steps. We end up getting that the r, value of r, measure of angle r I should say, is actually 82 degrees. From here, I'm going to use the law of sines again. Shrink that down. We are going to find the measure of angle S. So, I need to take 12 squared is equal to 14 squared plus 9 squared. Once again, kind of like modified Pythagorean theorem. And we take 2 times 14 times 9 cosine of S. So we're almost done here. All right, 252 cosine of S running out of room here. So we're going to take the inverse cosine of 133 over 252. Just going to change this guy out. We end up getting that this is equal to 58 degrees. And then when you go ahead and check these, we end up getting 82 plus 58 plus 40 is equal to exactly 180. So that's good for us. We finished it up. Nice job. Solve that triangle. And this last side is just about solving triangles. To solve a right triangle, you can use these different things. To solve any triangle, you can use law of sines or law of cosines, just based on what you're given. All right, that's all.